this lesson, we are going to be defining what factoring is, and then to be able to factor polynomials using the GCF. Remember, that is the greatest common factor. What we will have learned in our previous lesson is that we can multiply polynomials together. So when I multiply 5x times 3x, 3 times 5 is 15, and x times x is x squared. 5x times negative 7 gives us negative 35x. It is our polynomial written in standard form with no other terms to combine. If we have an example like x plus 6 and x minus 5, using the distributive property, I can multiply x times x, which is x squared, x times negative 5, which is negative 5x, 6 times x, which is 6x, and 6 times negative 5, which is negative 30. And when I combine like terms, I have x squared. Negative 5 plus 6 would be positive 1x minus 30. This is my polynomial written in standard form. Our purpose in this lesson is to be able to take these polynomials, these products, and to find out what did I multiply together in the first place. These are called the factors. Factoring is basically reverse multiplication of the two polynomials. So when we are factoring, we want to be able to figure out what did we multiply together that would give us our numbers to begin with. So that's our purpose for today. How do we do that? We're going to start with the greatest common factor. That is the highest number and or could also be a variable that divides into each term evenly. We will always check and factor out the greatest common factor first before doing anything else. Here are some examples. We have 4x cubed minus 2x squared minus 6x. First of all, we're going to take a look at our coefficients, and we want to know if anything can be divided evenly into our coefficients. It looks like we could divide all of them by 2. Next, we're going to take a look at our variables, and we want to see what could divide evenly into each of our variables. To do that, we find the base that's alike, which is our x, and then we take a look at the exponents, and the smallest amount of exponent present is what we can divide out of each of them. So that would be x to the first power. Now what we do is we simply divide each of the terms individually by our greatest common factor. So 4x cubed divided by 2x. 4 divided by 2 is 2. X cubed divided by x, we keep the base, and remember when we divide, we subtract the exponents. So if I have 3 x's and I take one of them away, I have 2 left. Next, I have negative 2 divided by 2. That gives me a negative 1. Keep the base, which is the x, and take a look at the exponents. 2 take away 1 would leave me with 1. Next, I have negative 6 divided by 2, which is negative 3. The base is an x, but I have an exponent to a 1 divided by exponent to a 1. Anything divided by itself would be 1, and so I have taken out the greatest common factor. Let's take a look at example B. First, take a look at the leading coefficients, or just the coefficients. What do they have in common? In this case, it's a 5. Next, let's look at the variables. They both have an x in common, so that is our common variable. Then we're going to take a look at the exponents, and what we would be able to divide by is the smallest amount, so it goes evenly into both. Then we're going to divide each term by 5x cubed. 5 divided by 5 is 1. And if I have an x to the 5th divided by x cubed, I keep the base and I subtract the exponents. Next, I have 10 divided by 5, which is 2. And I take a look that I have an x cubed and an x cubed. And when I divide those, I get 1. And therefore, that is my solution. of dividing by the greatest common factor. Let's take a look at another example. So we have 3x squared minus 18. What do they have in common? Well, first of all, let's take a look at the coefficients. It looks like they have a 3 in common. So we're going to divide by 3, and then when we divide 3x squared by 3, we get x squared, and when we have negative 18 divided by 3, we get negative 6. Notice that we did not have a variable in common, so a variable was not part of our greatest common factor. Example D. Our coefficients are 6 and 3. They have a 3 in common. We have variable y and y, so we keep the base and we look at the exponents, a 4 and a 2. The smallest amount is a 2, so that can become our greatest common factor. Now we divide. 6 divided by 3 is 2. Keep the base and subtract the exponents. I have 4 y's, and I'm going to take away 2 of them. I would have 2 left. 3 divided by 3 is positive 1, and y squared divided by y squared would be 1. So we have taken out the greatest common factor. In our last example, notice we do not have any numbers other than the coefficients of 1. So we'll start with our base. We do have a variable in common. We have an f, and this is to the exponent of a 1 and a 4. So the smallest amount that we can divide out would be a 1. Then we have our g as our other variable that's in common, and we have a 3 and a 2. The smallest amount of exponent is a 2, which can be divided evenly out of each of those terms. F divided by f is 1. G to the third divided by g squared. We keep the base and subtract the exponents, which is to the first power. Let's go to the next term. F to the fourth divided by f to the first. Keep the base. 4 minus 1 would be 3 left over. And g squared divided by g squared is 1. When you are multiplying polynomials, factoring polynomials, remember that factoring is really reverse multiplication. We are always going to factor out the greatest common factor, the GCF, first. And remember, the GCF can be a variable or variables, a number or numbers, or both. Please remember to complete the reflection.